insurance. What we can also see at the very end is a column called is fraud. So what we have in this table is knowledge for, actually there's about 2,000 rows in this table. So for about 2,000 insurance claims, we know which ones are fraudulent and which ones are not. We know that from historical data. Now what we want to do is to use this knowledge of which ones actually are or aren't fraud across the combination of all of these different columns, all the pieces of information, to try to build a model to classify that effectively, to build a model that will allow us maybe to identify, if we get the same bits of information for new insurance claims, which ones may or may not be fraudulent, because they may fit the patterns that are identified when we do the initial analysis and training of our model. So that's the auto claims fraud. Now, if we look, we also have an auto claims new. This is the data we might have as maybe 147 rows here, where we've got the claims. So these are new claims where we don't know at this point whether they're fraudulent or not. But what we'd want is maybe the APL to help us identify that, so we can target which of these claims we should perhaps investigate further to maybe check out that they could potentially be fraudulent. So that's what, of course, predictive analytics and data mining brings to the table. So how do we actually make that happen with the APL? Well, there is an example that actually works on these sample tables available. So you don't have to sit there and write any script from scratch. If we go into the samples folder that we downloaded and extracted in the previous video, you'll see that there is an APL insurance fraud folder within the SQL folder. And in there you'll find there are 3 SQL files. So the first one is called claims table types. And as you remember from previous videos, to actually work with the wrapper generator, just like if you're using the PAL, a regular predictive analysis library with HANA, you need to use the wrapper generator, and it works on the basis of having table types or structures of what the table looks like, not the table itself, just what the table structure is, rows and columns, and just column definitions and what type and name, etc. So you need to specify those when you're setting up your APL procedure. So what we've got here is the code that for those 2 input tables we were just looking at, we can see here are the table types that actually have those column names and their type, and saying which one is the primary key, for example. So for the new types, so in this case we don't actually have the is fraud, and we have the actual historical claims where we do know whether they're fraud or not. So the first thing would be to do is to connect, and we do that with our APL user. We have the rights to work with this and run that. Don't worry if you get an error on the drop, it just means that you didn't already run this previously. But if you needed to make a change and then rerun, it's quite nice to have the drop in the code, because it prevents you having to go and manually do it each time. So what we've done in this code is we've created the 2 table types, so we can actually refer to the structure of these 2 tables when we come to make our code. So the next thing we would do is we want to do the training, effectively create our model. And for that, there's a claims APL create train SQL file. And what this one will do is it basically runs the code that you'll need to do to actually call the wrapper generator, which is something you see for all AFL functions, whether it's the PAL, the BFL, or the APL, to actually build as a stored procedure that focuses on the structure of data we're going to work with, in this case the auto claims fraud data. So what we can see here, we've got the code, and you'll find more about it in the reference guide as well. So we're going to firstly actually create a table, which is going to be what we call our signature table. And this is where, in this table, the signature, we're going to put in a row that represents all of the other table types that are appropriate to this procedure. Now, of course, that depends on which procedure you're going to work with. In this case, it's the create, model, and train procedure of the APL. So this, again, in the manual, you'll find information about which ones you need and which ones are input types, which ones are output. But it's very nice that in the APL you get a sample showing you the code, so you can just take this and maybe adapt it to your input data type. But a lot of the common stuff here will probably remain the same. So we've got that there. What we then will do is generate the procedure So if it was already existing, we would call the drop. Otherwise, we would call the wrapper procedure create. Again, this is standard for the AFL, and this is the syntax we use with SPS 09 of the AFL. And then we're going to create for the APL area. So we're saying here it's an APL function. We want to call the create model and train. This gives the name of our user and the schema we want to put it in where we want to put the stored procedure, and then we actually give the name for the procedure we're going to create. And then we'll give as an input this signature table, and that then passes in all the information about the input and output tables that we're going to have. So we've now set that up. Let's actually go and run that code. So we generate our procedure. Of course, the first thing we would need to do is just connect. So let's connect as our user APL, and let's run this code. Don't worry again about that drop table, but what we should see now is that the wrapper procedure create ran, and we can see that ran very well. So we've managed to create our procedure. So once we've created the procedure, which is really just a one-time thing unless your data structure changes, we now want to actually start running the training process. So for that, we need to put some values, some rows into some of these input table types because we need to basically specify what it is we're going to work with. So for example, there are a number of different types. Again, the documentation gives more detail on these, but there is something called a functional header. Okay, we'll call that claims. That's the ID. And then we have configuration for the create and train process. So here, for example, we specify some APL specific values. So the model type we want to use. In this case, we're going to do a regression or classification, because in the APL, those two are actually basically the same thing. They're joined together as a function. We can also say for the input data, do we want to take all of it, or maybe we want to do some cutting, some filtering of the input data, some sampling. And that's something that the APL has a number of features for. And what we're going to say this time is cutting strategy can be a random cutting without doing any testing. So again, these are things you'll find more detail on in the reference guide. Then we actually have to give some specifications on what the variables we want to use are. So basically, the claim ID is going to be just the ID. That's not something that's normally going to be relevant to whether or not the claim is fraudulent. But then all of the other items are going to be something we want to analyze as part of our classification, except for the last one, which is our flag saying, is this fraud or not? So actually for this one, we say something different. We're saying this is a yes, no flag. And this actually, it's normally in the case of the APL, the very last column is the one that actually has the known result in this case, whether it's fraudulent or not. So that shows the structure of our training data. Here we can see actually we explicitly say that by not creating a target column, that's why it takes the last column in the training data as knowing that that one is the result we're kind of training for, we're looking for. We need to actually create the output tables. Now we can do that very easily because we've got table types, so we can just use the like on a create table. You can create column tables, or in this case we're creating row tables in HANA. And then you can actually call your function. So let's go just and run the code here that's going to actually do the setup. So let's go to create these tables. As far as actually running the function, let's run that code. Okay, it'll run fine. Ignore the errors on the drop because it's the first time. And then we have the code that actually will perform the training phase. So this is where we call the code that actually will run the training for us. So it's going to call our procedure, which we choose to call APL wrapper create model and train. That was the name we chose when we created this procedure, and we just ran out a minute ago, with these input table names and then all the output table names. We've got our actual business data also specified. These are all input or output parameters. So we can actually call our procedure, and this is where it actually is going to do the training and try to establish what the best model will be for that. So we can see that that's run, and we've actually got 4 output tables. So what we can now do is look at those output tables because it will give us an idea, for example, of how good the model is that we've built. So we can, for example, go to the indicators table, which is one of our output tables, and we just run a quick select on that. Again, it's nice that we have this in the code, and it's doing some a little bit of manipulation as well. We can now see two very important quality indicators, the KI and the KR. More about what those mean in the reference guide for the APL. But you can see we've got a 69% and 93% quality, so we're looking reasonably good in terms of our model that we've created. It looks like a pretty stable and valuable model. And if we want, we can actually see the contributions here. Again, we'll just run this code. We can see that for each of the input columns, we can see a ranked list showing how much they contributed. So it looks, when we're looking at fraudulent claim, from what we've learned in the model, it looks like the amount of bodily injury seems to be pretty important. It's actually nearly half contributions have maybe a high bodily injury amount, and also the number of days it takes to report. So that's already giving you some idea of maybe how you're going to be able to identify the fraud. You don't need to know this because actually we'll have a procedure that will do it for you, but it's good to get an understanding and just realize how your model has been structured and what is significant and what isn't as part of your validation phase you do when building a model. And finally, what we can also see is a little report just showing some overall stats about the model we've created, again from the output table. So here we can see, okay, 15 variables. There were 13 explanatory variables, or ones we're going to use to actually build our model from. We had a 2,000 claims, so 2,000 input records, and it took about 1 second to do its learning process. So again, there's some just more information. So these selects are basically all going against the output tables that were created for us in our user_APL schema, so our user schema. So we've created our model. That's great. We're good to go. What would be great now is to actually look at these new claims and identify which one of those may or may not be fraudulent. So for that, we'll go back to the sample code, and this time we'll go to the APL apply SQL for claims. And what we'll do for this one, let's just connect it to the HANA as a user APL connection. What we're going to do here is something very similar. We're going to actually build a procedure using the wrapper generator. We're going to need some table types, for example, for the output type, some things that may not already exist in the standard table types that we installed earlier. We can see here we've got actually 4 input tables and 2 output tables, and this is going to call a procedure which is called apply model. And again, more about that in the APL Automated Predictive Library reference guide. But the apply model basically allows you to take a model that you've previously built, pass it some input data and maybe some other parameters, and then it will then try to forecast or predict for you what value it is you're looking to predict. In this case, is it or not a fraudulent insurance claim, or is it likely to be one? So this is the code we're going to run to create our model. So let's just go and run that. So let's run the code. Again, this is something you only need to do once to actually create your stored procedure. Ignore it if you get an error on the drop. It's normal the very first time you create something. Then we need to actually create our inputs. Now the input data, the auto claims new, already exists, so we don't have to do anything with that. However, we can specify some parameters, some configuration. So for example, we can specify the APL apply extra mode, in this case with a value of decision. More about that in the reference guide, but here you can set up basically the parameters that you want to use. And we specify and create our output tables as well. Then finally, we run the code. So let's go and take this, let's apply and actually go and run. So this time we're going to go and actually one of the inputs here is the output of our previous, our training phase becomes the input because we need to pass it the model. So we now run that and you see it takes a few seconds and actually 2 seconds and it's now actually done our predictions for us. So we're ready to actually go and look at the output tables, which is the claim scores and potentially the apply log. So if we look at the claim scores, again, we've got a nice select here in the example, so it makes it very easy. What we're able to do is identify now what our claims may be in our 147 different inputs. we can see for these claims, in fact, it's just the ones here, these are fraudulent or likely to be, and what the percentage is. So it's not just telling us whether or not it matches this is likely to be fraudulent or this is like